Good day, guys. Today we will be studying about Coulomb's law, the lawmaker, and the law itself. So sit back, relax, and stay educated. Charles Augustin de Coulomb, born on July 14, 1736, was born in France, son of both Henry and Catherine Coulomb. Their family moved to Paris on his childhood. He is a quite smart-headed person. He had finished his studies in philosophy, language, and literature, with also some background in mathematics, astronomy, chemistry, and botany. So now that you had a brief background check of the lawmaker Charles Augustin de Coulomb, um, so now let's go to the law. Now let's define Coulomb's law. Coulomb's law is the mathematical description of the electric force between charged objects, formulated by the 18th century French physicist Charles Augustin de Coulomb. It is analogous to Isaac Newton's law of gravity. Here are the formulas of Coulomb's law. This is the main formula. F is equals to K Q1 Q2 all over R squared. Please don't mind the typographical error that happened in that screen. And F is equals to force or N, which is equivalent to Newton. The distance is R, which is equivalent to M, and M is equivalent to meter. Q1 and Q2 are the charges, which is coulombs. The constant K is equals to 9 times 10 raised to 9 N times M over C squared. Here are some things to remember when tackling Coulomb's law. Positive plus positive charges will repel. Negative plus negative charges will repel also. The only charges that will attract are both positive and negative charges. It means that different polarity attracts, but the same polarity repels. Here are the things to remember. These are also things to remember when you are tackling about the Coulomb's law. Charges is proportional to the force. So meaning, if the charge goes up, the forces will go up too. But the distance and the forces are inversely proportional. So that means when the distance are getting longer, the forces is getting lower. Two charges of magnitude 1.8 times 10 raised to negative 17 coulombs are separated by a distance of 150 nanometers. What is the size of the electrostatic force experienced by each charge? Q1 and Q2's value are the same, 1.8 times 10 raised to negative 17 coulombs. The distance is 150 nanometer, which is, if we convert it according to the SI unit, the equation is F is equals to 9 times 10 raised to 9 and M squared, C squared. Open and close parentheses, 1.8 times 10 raised to negative 17 C squared over 150 times 10 raised to negative 9 M. Sum that equation up in the calculator, you will have the result of 1.3 times 10 raised to negative 10 Newton. And so that's it. It's so easy. It's so easy to learn. That's all for today, our dearest physicists. I hope that you had learned something from this little blog that I make. Thank you for listening. Stay educated.